All right, adding integers is something that we've been doing since about second grade, maybe first grade. Positive integers are greater than 0. So I'm showing all positive integers 1 through 15 on my number line. I have an arrow to indicate that it continues. This continues in the negative direction. The next number will be 0, and then we get into our negative integers. That continues in a positive direction. Now, we've been doing this for years. We know that we can go on a number line and mark down 5, and then we can add 3 by going 1, 2, 3, and our answer would be 8. Most of us do not use a number line. I'm just showing you how you could use it. 9, and we add 4, so we continue positive. 1, 2, 3, 4, and it equals 13. We even can do 6. Let's go ahead and mark out 6. And let's go ahead and do 7 more. 1, 2, 3, 4, 5, 6, 7. And we find out that 6 plus 7 is 13. Nothing changes when you add integers that are positive. A positive plus a positive equals a positive. That's the rule. A positive plus a positive equals a positive. Nothing has changed. A positive plus a positive equals a positive. We now have our negative integers. And you'll find out that all negative integers are less than 0. So we go -1 all the way down to -15. This would continue to be more positive. The next number would be 0. All negative integers are less than 0. Now we have addition. This is integer addition. So we have a -3. So let's go ahead and put a dot over -3. And then it says to add -4. One thing I need to tell you about negatives, it automatically changes directions. Normally we count going higher in that direction. Because it's a -3, we've already had to move in the negative direction, and we move 3 places. So we're adding, that would tell us to go back to a positive direction, but that tells us, that negative tells us to switch directions and start adding in this direction. So we have -3, we went in this direction to find out -3. It says plus, normally we would go in this direction when we add, but we're adding a -4, so we go back in that direction. So we count 1, 2, 3, 4. -3 plus -4 is -7. All right, let's look at the next example. -7. We find our -7. We mark our -7. We had to move in the negative direction to get to 7. 1, 2, 3, 4, 5, 6, 7. So we moved in the negative direction. Told you that tells us to change direction from where we would normally go. If it was positive, we'd move in the positive direction, but that's -7. So we change directions and go that way. Addition tells us we should be adding, so we should be prepared to go in that direction, but we're adding a -8, so we switch directions again and we continue that direction. So -8, 1, 2, 3, 4, 5, 6, 7, 8. -7 plus -8 is equal to -15. I guess if I was doing a better job, I would put this in parentheses, -7 plus -8. So we know that's our solution. We could put in parentheses over here, -3 plus -4. That would be our solution. I bet you can figure out that -10 plus -3 is going to be -13. All right, let's look at what the rule says. Negative plus a negative is going to equal a negative. We check it again, we still have negative plus a negative, and it still equals a negative. And of course, -10 plus -3, because it equals -13, it tells us that negative plus a negative is a negative. Integers are numbers that are greater than 0, those are your positive integers, and numbers that are less than 0, those are your negative integers. So what I have here is a number line But one of the first things I want to talk about is absolute value, because that's what you're going to need when you add integers with different signs, positive and negative. So the first thing is absolute value is symbolized by two vertical lines where x is the integer. So we read this as the absolute value of x. We can substitute any number in there, and the absolute value is the distance an integer is from 0. So if we were to pick a random integer, and we say, well, what is the absolute value of 4? The way that would be written is, what is the absolute value of 4? Again, we have the two vertical lines indicated, and then we can use the number line, and it is always referenced to 0, and it is distant, so we can count 1, 2, 3, 4. The absolute value of 4 is 4. 4 is 1, 2, 3, 4 spaces from 0. Oh, excuse me. That's the absolute value of negative 4. Excuse me, I made a mistake. If we go on the other side and we look at the absolute value of 4, which is what I said the first time, then you find out it's 1, 2, 3, 4 spaces from 0. You may have just realized that absolute value of 4 and negative 4 is the same thing. Can I tell you a little secret? Absolute value is always positive. The absolute value is the distance an integer is from 0. The absolute value of negative 5 is 1, 2, 3, 4, 5, because it is always positive. The way you would see that written is the absolute value of negative 5 equals, and we would go 5 because it's 1, 2, 3, 4, 5 spaces from 0. The absolute value of 7 is equal to 1, 2, 3, 4, 5, 6, 7. The absolute value is the distance from 0, and it is always positive. We have a number line that has both our positive and our negative, and we know that 0 is neither positive nor negative because it's just in the center. It's a placeholder. All right, so let's begin and examine what happens when you have a positive plus a negative. So we have a positive 7. Let's go out to our 7. Let's plot our dot. Positive takes us in this direction, and we're adding a negative 9. And I said every time you get to that negative, you change direction. So we have to count in that direction. So we start from 7 and we count 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I end up at negative 2. My answer is negative 2. That's the solution to 7 plus negative 9. Next one, we have a negative plus a positive. All right, so again, because it's negative, we start off in the negative direction and we find out negative 6. We can put our dot there. Look at what we're adding. We're adding a positive, so we're going back in the positive direction. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I end up on 6. I'm plotting my solution as negative 6 plus 12 is that dot right there, which equals 6. Let's look at negative 6. Again, we're starting off in the negative direction, and then it says we're adding 4, so we're going in the positive direction. 1, 2, 3, 4. Our answer here is negative 2, and we're going to plot that as negative 6 plus 4. The rule for adding different signs is you find the higher absolute value. So I'm going to compare the absolute value of 7, and I'm comparing it to the absolute value of negative 9. And the rule says you keep the sign of the higher absolute value, and then you subtract the lesser value. So the absolute value of negative 9 is greater than 7, so I'm going to do minus 7, and my answer is going to be 2. And in my problem, it started off as a negative 2, so my answer is going to be negative 2. Keep the sign of the higher absolute value, then you subtract. In this case, we're going to compare the absolute value of negative 6, the absolute value of 12, and we find out that 6 is less than 12. My higher absolute value is a positive number, so my answer has to be positive because the rule says you keep the sign of the higher absolute value, then you subtract. So now I'm subtracting 12 minus 6, and my answer is 6, and I bring it up here, and it's positive. I'm going to compare the absolute value of my negative 6, absolute value of 4. Absolute value of 6 is 6, 4. 6 is greater than 4. My 6 was originally negative, so I know my answer has to be negative. I take the higher number and I subtract the lesser number, the greater number. 6 minus 4 equals 2. My answer is going to be negative 2. The rule is keep the sign of the higher absolute value, then you subtract. When adding different integers, you keep the sign of the higher absolute value, then you subtract. All right, again, before we continue on to our integer rules with addition, we need to talk about this thing called an additive inverse. The additive inverse always equals 0. Opposite signs, but the same number. Okay? So the additive inverse of negative 3 is 3. Opposite signs, one's negative, one is positive, added together, and if you don't believe me, let's rearrange the way we have it written. 3 minus 3 always equals 0. Additive inverse. Additive inverse of 180. And I know it's not on the number line, and it's okay. This is positive. The additive inverse is the same number with a negative sign. Additive inverse of 180 is negative 180. Additive inverse of negative 6 is 6. They have the same absolute value. One's going negative, one's going positive. They will always equal 0. They are opposite signs. One's negative, one's positive, but they're the same number. That is all an additive inverse is. Now that we have the definitions, we can talk about adding integers. Okay, we're looking at our rules for subtraction. I'll remind you that 0 is neither positive or negative, but it is the reference point. All of our negatives are less than 0. All of our positives are greater than 0. The direction for our positive is this way, and the direction for our negative changes to that way. Our first problem is 7 minus 3. So we plot out our 7. Minus tells us to go in that direction. So we count 3 because there's nothing to change direction. 1, 2, 3. 7 minus 3 is 4. All right, let's look at the next iteration. We start off with 5. Let's go ahead and put a dot for our 5. And subtraction takes us in the negative direction. So we're heading in that direction. But there's a negative sign that changes our direction. So we have to go positive. 1, 2, 3, 4. And we find out that 5 minus negative 4 is equal to 9. All right, we start off with a negative 4. The negative tells us to go 1, 2, 3, 4. So we have our negative 4. Minus sign tells us to continue going this way. So we continue 1, 2, 3, 4, 5. And we find out that negative 4 minus 5 is negative 9. Last one, and we'll see if we can figure something out from this. The last one is negative 1. The minus sign tells us to go this way. The negative tells us to go that way because it changes our direction. So we count 7. 1, 2, 3, 4, 5, 6, 7. Our answer to the question of negative 1 minus negative 7 is 6. All right, the rule is keep, change, change. So we keep our 7, we turn it into addition, and then we have negative 3. And we know that that's 4. All right, again, our rule for subtracting integers is keep the first integer, change the subtraction to addition. So we keep the 5, that becomes plus, and we change our number to the additive inverse or to the opposite number. And then we follow our addition rules. We keep, change, change. Now I told the class one time that some students of mine will get these problems wrong because they don't want to draw these two lines that breaks up the subtraction from the actual number. As in this case right here, the subtraction sign is a negative sign, and our -4 indicates that we should change that to the opposite, which is 4. In this one, we keep our -4, change subtraction to addition. That's a +5, so it becomes a -5. The rule for addition is negative plus a negative equals a negative, and we get our answer. We keep, change, change. Keep -1, change subtraction to addition, -7 to its additive inverse, which is 7. -1 plus 7, the rule is keep the sign of the higher absolute value. 7 is greater than 1. 7 is positive. Our answer is going to be positive. 7 minus 1 equals 6. 3 times 4, we can skip count. 4, 8, 12. And you're welcome to skip count. I probably won't skip count any of these other examples. We'll just use our math knowledge, but feel free to skip count in your paper if you need to. 3 times 4 equals 12. 24 divided by 8, well, I know 8 times 3 is 24, and I can prove it by going 8, 16, 24, so my answer is 3. We have a positive times a positive, and it equals a positive. We have a positive divided by a positive, and that equals a positive. We have -5 times -15. 5 times 5 is 25. I'll bring my 5 down, carry my 2. 5 times 1 is 5 plus 2 is 7. Notice that as I multiply, I'm not concerned with the negative or positive signs. I figure that out at the end. Negative times a negative equals a positive. Anytime I have two negative integers or an even number of negative integers in my multiplication problem, the answer is going to be positive. We have -35 divided by -7. I'm going to do the math. 35 divided by 7 is 5, and then I'm going to figure out the rule. I have a negative divided by a negative, and the answer is positive. If I have two negatives in my division problem, or even number of negative integers in my division problem, the answer is going to be positive. Now we have -8 times 7. Again, I'm going to do the math. 7 times 8 is 56, but I only have one negative integer, and that's an odd number, not an even number. And we know that negative, or we're learning that negative times a positive is going to yield a negative. And down here I have 9 times -11, and it's going to be 99. I have an odd number of negative factors, so I have a positive times a negative. With an odd number of negative factors, it's going to be negative. Over here we have a -48 divided by 6. The answer is going to be 8. I have an odd number, so my answer is negative. So I have negative divided by positive equals a negative. I have a positive divided by a negative. That's going to be 10. 12 goes in 120 10 times, but I only have one negative integer, so I have positive divided by negative, and it equals a negative. Here's the rule. Same signs equal a positive. Different signs equal a negative. Positive times a positive, or negative times a negative, equals a positive. Positive divided by a negative, or negative divided by a positive, will equal a negative. Learn those two rules, and you'll have no problem at all with multiplication and division.